Hello and welcome to Precalculus lesson number 8. In this video, we're going to learn about absolute value equations and inequalities. Before we do that, however, let's go ahead and review what is meant by absolute value itself. There are two approaches to defining the absolute value of a real number: the algebraic approach and the geometric approach. The algebraic approach to defining absolute value is as follows. For all x belonging to the set of real numbers, the absolute value of x, denoted by x with a double bar around it, is defined as follows. The absolute value of x is equal to x itself if x is greater than or equal to 0, and the opposite of x, or negative x, if x is less than 0. So, for example, if you look at the absolute value of 5, that falls into this category because 5 is greater than or equal to 0, so the absolute value of 5 is just going to be 5 itself. But if you look at the absolute value of negative 5, now x lies in this category, which is because negative 5 is less than 0. So the absolute value of negative 5 is going to be the opposite of negative 5, which turns out to be 5 as well. So this is the algebraic way of dealing with absolute values. In words, the absolute value of a real number is the number itself if the number is non-negative. The way you read this, x is greater than or equal to 0, is you say x is non-negative. So that means it's either greater than 0 or equal to 0. So instead of saying that, you can just say it is non-negative. And the opposite of the number if the number is negative. Note that it follows from the above definition that the absolute value of a number is never negative. X is greater than or equal to 0 is the symbolic way of saying x is non-negative, and x is less than 0 is the symbolic way of saying x is negative. Let's take a look at a few examples that we can look at. We just saw the first two. Absolute value of 5 is, of course, 5 itself, right? Absolute value of negative 5, as we know, is going to be the opposite of negative 5, which is 5. The absolute value of 1/2, because 1/2 is greater than or equal to 0, in other words, because 1/2 is non-negative, is going to be itself. The absolute value of negative 1/2, because negative 1/2 is less than 0, is going to be the opposite of negative 1/2, which is 1/2. And the absolute value of 0, of course, is 0, because 0 lies in the first category. Let's take a quick look again. So if it's greater than or equal to 0, it's going to be itself. And 0 falls in that category, so the absolute value of 0 is 0 itself. Now, the geometric approach to defining absolute value is much more intuitive because it says for all real numbers x, the absolute value of x, denoted by the same notation with bars around it, x with bars around it, is defined as follows. The absolute value of x is the distance between x and 0. So this takes care of the problem of absolute value very, very quickly and efficiently, because if you look at negative 5, for example, what is its distance from 0? Well, it's 1, 2, 3, 4, 5 units. That's why the absolute value of negative 5 is 5. What is the absolute value of positive 5? The same, because the distance between 5 and 0 is also 5 units, right? The distance between two numbers is the number of units that separates them, right? So for both of those, we get 5. Note that it follows again from the absolute value, the definition that the absolute value of a real number is never negative from this geometric approach as well. This is because in this interpretation of the absolute value is a distance, and if you think about it, distance is never negative. The shortest possible distance is 0, which is the distance between a number and itself, right? We conclude that the absolute value is never negative either. Now we're looking at these with the geometric approach, right? Notice that the distance between 5 and 0 is 5, so this is going to be just 5. The distance between -5 and 0 is also 5 units, so that's going to be 5. The distance between 1/2 and 0 is 1/2. The distance between -1/2 and 0 is also 1/2 a unit. And the distance between 0 and itself is, of course, 0. So we get the same results that we did using the algebraic definition or interpretation of absolute value. We note that the geometric interpretation of absolute value is more intuitive, and that is why the geometric interpretation of absolute value is the one we will use to solve absolute value equations and inequalities. Let's start by looking at absolute value equations. All right, let's say we want to solve absolute value of x equals 3. The thing that you need to do is basically interpret that for yourself. What is this problem asking me to find? Well, it's asking me to find all real numbers x such that, or let's put it a different way, whose distance from 0 is 3, right? Remember, the absolute value of x is the distance between x and 0. So I'm looking for all numbers whose distance from 0 is 3. And of course, as you know, there are exactly two numbers that satisfy that requirement, namely 3 and -3. So when I see this equation and I jump to this conclusion that x is equal to 3 or x equals -3, this is an interpretation. I'm not doing something like adding something to both sides, subtracting from both sides. I'm not applying a basic operation to both sides. I'm interpreting what that means. So this is important to understand. And if we want to write the solution set, we can just say the solution set contains the set of the numbers 3 and -3. Remember, order does not matter in sets. Or I can use the compact notation and just say s equals plus or minus 3. These two are basically the same set. All right, so that's simple enough, right? Now, if we make it a little bit more complicated, but we deal with it the same way, because you can think of whatever is inside the absolute value as some number, right? Now we're saying the absolute value of some number is 3. That means what? That means the distance between that number and 3 is 0, so that number must be either 3 or -3, right? So in this case, that number happens to be x minus 2. So x minus 2 is either 3 or -3. Now we just need to solve these two simple equations that come about. So we move the -2 to the other side. We get x equals 3 plus 2, or x equals 5. And here we do the same. We get x equals -3 plus 2, so x equals -1. So once again, we have two solutions. So the solution set contains -1 and 5. All right. Now you can quickly check them if you like. For example, if you want to check x equals -1, we want to see if the absolute value of -1 minus 2 is equal to 3, right? Now the absolute value of -3, is that equal to 3? Now we know the absolute value of -3 is 3, so we end up with a identity, so it checks out, okay? So it makes the equation true. You can also check x equals 5. So you have absolute value of 5 minus 2. You want to know if that's equal to 3. Now that's going to be the absolute value of 3. You want to know if that's equal to 3. Now we can drop the question marks because we know that absolute value of 3 is 3, which is equal to 3. So this checks out as well. And this indeed is our solution set. They both work. All right, so simple enough. Make sure you understand it and we'll move on. All right, how about this one? try it on your own first, pause the video, and then come back. All right, as you may have guessed, we need to isolate that absolute value term, right? So we're going to go ahead and add 4 to both sides to move the negative 4 over. So we get 4 absolute x minus 2 equals 4 plus 3. So we get 4 absolute x minus 2 equals 7. Notice I'm not doing anything to the x minus 2. It doesn't change because I'm keeping the absolute x minus 2 intact until the moment of interpretation, okay? So now I divide both sides by 4. I get absolute x minus 2 equals 7/4. So now we know that the absolute value of some number is 7/4. So that number can only be what? Either 7/4 or negative 7/4, right? So x minus 2 has to be either 7/4 or it can be negative 7/4. Those are the only two numbers whose absolute value is what? 7/4. So if the absolute value of some number or some expression is 7/4, that number or that expression has to be either 7/4 or negative 7/4. Now we're going to solve this quickly by clearing the fractions by multiplying both sides by 4. So don't forget, because of distribution, you have to multiply both terms on the left side by 4. So we get 4x minus 8 equals 7. So now we move the negative 8 to the other side. Changes sign, becomes positive. So 4x equals 7 plus 8. So 4x equals 15, or x equals 15 over 4. Now on the other side, on the other equation, we'll do the same thing. We'll multiply both sides by 4 to clear the fraction. So we have 4x minus 8 equals negative 7. Those 4's cancel out. So we get 4x equals negative 7 plus 8. So 4x equals 1. Divide both sides by 4 and we get x equals 1/4. All right? So our solution set is going to contain 1/4 and 15 over 4. We have two solutions. Make sure you're comfortable with that and you can do it on your own, and we'll proceed. Try this one, see what you get, okay? Then come and see if it's the same thing that I get. Well, this is pretty simple, right? I just wanted you to know sometimes there are other letters, so you treat them just like x. So the absolute value of some number is 19. So what does that number have to be? That number has to be either 19 or it can be negative 19, because those are the only two numbers whose absolute value is what? 19, right? So now we get 2u equals 19 minus 6. 2u equals 13. Divide both sides by 2, so u equals 13 over 2. Or here we get 2u equals negative 19 minus 6. So 2u equals negative 25. Divide both sides by 2, you get u equals negative 25 over 2. So our solution set contains 13 over 2 and negative 25 over 2 in no particular order. All right, so that's a simple one, right? Let's move on. All right, go ahead and try this one, see what you get. Okay, so I'm hoping you did this. We know that we need to isolate the absolute value term, right? So we get absolute 4 minus 3/4 L equals 5 plus 2, so 7. Now we're ready to interpret. The absolute value of some number or expression is 7, so that expression can only be one of two things, right? You guessed it, either 7 or 4 minus 3/4 L can be -7, right? We'll go ahead and quickly solve this by multiplying both sides by 4. So and we'll do that on both equations. So in the first equation, we end up with 16 minus 3L, right? Because notice those 4's would cancel, is equal to 28. So negative 3L equals 28 minus 16. So negative 3L equals 12. Divide both sides by -3, so you get L equals -4. On the second equation, we get 16 minus 3L equals -28. So -3L equals -28 minus 16. So -3L equals, let's see, that's 30 and then 14, so 44, so -44. Divide both sides by -3 and you get L equals 44/3. All right, time permitting, you should always check your answers at the very least on a calculator and make sure that you've obtained the right answer. So here we will get the solution set is equal to the set containing -4 and 44/3. Let's see how we could quickly check that on a calculator. All right, so on this particular calculator, HP prime, we can find the absolute value right here by clicking on this button, and there's the absolute value. So we're going to type it just as we see it. So we have 4 minus 3/4, and we're going to multiply that by, let's try -4 first. Don't forget to use this button for a sign and that for an operation, okay? Like if you want minus, you use that. If you want a negative for -4, you use that particular button. And then -2. Now, once I hit enter, what am I hoping to see? Obviously 5, right? But notice what happened here on the display. I just realized no, we're fine. I thought that the -2 should have been inside, but it's not, so it's outside. We should be good. We're going to hit enter and we get 5. Okay, so we know that that was correct. Now, the nice thing about these calculators on a PC is that you don't have to retype the whole thing again. If I just double click it, it'll repeat it, and all I got to do is go in here and change that -4 to what? To the other value that I'm checking. 44/3. Okay? Now, once I hit enter, I better see 5 again, right? And we do. So there's at least a quick check on a calculator, if nothing else. All right? Let's go ahead and take a look at a few special cases. All right. What about this equation? Absolute x equals 0. We're looking for all the real numbers whose distance from 0 is 0. Well, remember, there's only one number that satisfies that, right? And that would be what? 0 itself. All right. How about this one, the next one? We want the absolute value of this particular expression to be 0, right? Well, if the absolute value of an expression is 0, that means that expression better be what? Better be 0, right? Because that's the only number whose absolute value is 0. So here we say x minus 2 equals 0. Remember, we're interpreting, right, what that means. So then we just solve for x, so we get x equals 2. All right, so for the part A, the solution set just contained one element, 0. For part B, the solution set contains the number 2. How about this next one? I'm looking for a real number whose distance from 0 is negative 3. Remember, distance can never be negative. So that means what? There's no such x. Well, there's no such real x. So therefore, remember the triangular formation of dots means therefore. Therefore, the solution set equals what? Empty. No solution. And of course, the exact same goes here. There's no way the absolute value of any number or expression can be negative, so same result there. That's empty as well. There's one interesting case, which is the absolute A equals absolute B case. So if the absolute values of two numbers are equal, what do you think they would have to be? Think about it, right? If the absolute values of two numbers are equal, they're either the same number, right? Or in worst case scenario, they're opposites, right? Like, look, we know that the absolute value of 5 is the same as the absolute value of 5, right? We know that the absolute value of negative 5 is the same as the absolute value of negative 5. And we know that the absolute value of negative 5 is the same as the absolute value of 5, and the absolute value of 5 is the same as the absolute value of negative 5. These are the only ways this can happen. So when two absolute values are equal, the numbers are either the same or they're what? They're opposites, okay? So that's all this is saying. We know that if absolute value of A equals absolute value of B, then either A must be equal to B or A must be the opposite of B. So equations of this type, there's only one thing that you have to be careful about. Sometimes generate what's called extraneous solutions or extraneous roots. So when you get this particular kind of an equation, go ahead and solve it using this fact, but always you must check the solutions at the end. Remember, checking for solutions is sometimes optional, right? There are other equation scenarios where extraneous roots become possible, so therefore with those, checking is not optional. It's part of the problem solving procedure, and that's the way it goes for this particular type. Let's take a look at one. All right, so here we have absolute 5x plus 8 equals absolute 5x minus 6. So you can think of this expression as A and this one as what? B. So we have an absolute value of A equals absolute value of B scenario. So either A equals B or A equals what? The opposite of B. So either 5x plus 8 equals 5x minus 6, or 5x plus 8 equals the opposite of 5x minus 6. So it's a very simple matter to solve these, right? So in the first scenario, when I try to solve this equation, right? Notice what happens. The 5x's cancel out. I end up with 8 equals negative 6. This is a contradiction, right? So no solution from here. But this one may work out. Let's see, we have 5x plus 8 equals negative 5x plus 6. So 5x plus 5x, moving the negative 5x to the left side, making it positive, equals 6 minus 8. So 10x equals negative 2. So divide both sides by 10. So x equals negative 2 over 10. Of course, you know that in mathematics, we always like the most reduced form of fractions. So that's going to be negative 1 over 5. All right, even though there's only one solution, we do need to check it. So we go ahead and check if absolute value of 5 times negative 1/5 plus 8 is equal to, here we have the question mark because we're not asserting, we're checking, 5 times negative 1/5 minus 6, right? In absolute value, of course. All right, so we want to know if the absolute value of, now 5 times negative 1/5, that's negative 1, right? So negative 1 plus 8, we want to know if that's equal to, on the right side, 5 times negative 1/5 is once again negative 1, so absolute value of negative 1 minus 6. Now, negative 1 plus 8 is 7, so we want to know if the absolute value of 7 is equal to the absolute value of negative 7. And of course, the absolute value of 7 is 7, and the absolute value of negative 7 is 7. So we do get an identity, and therefore, negative 1/5 does satisfy this equation and make it true. Therefore, it is a solution. So we can confidently write S equals negative 1/5, like so. Okay? And that's all there is to it. So just be careful, follow the rule, make sure that you check your answer. All right. So another one of those scenarios, right? Again, think of this expression as A, this one as B. So either A equals B or A equals the opposite of B. So 5y over 6. I think it's a good time to pause the video. You should be able to do this, right? Minus 5 is equal to y minus 7/6, or 5y over 6 minus 5 is equal to the opposite of y minus 7/6. So here we're going to multiply both sides by 6 to clear the fractions. So we end up with 6 times 5y over 6 minus 6 times 5 equals 6y minus 6 times 7/6, right? We're just distributing on both sides. So we notice that this 6 will cancel that 6, and on this right side, these two cancel. So we're left with 5y minus 30 equals 6y minus 7, right? So let's get the y's on one side. 5y minus 6y equals negative 7 plus 30. It might have been better to take the y's to the right side since the larger coefficient of y was there, but not a big deal. So we get negative y equals 23, multiply both sides by negative 1, so y equals negative 23. All right, so here we're going to distribute the negative first on the other equation on the right side. So 5y over 6 minus 5 equals negative y, be careful, plus 7/6. Negative times negative is positive. Again, we're going to clear the fractions by multiplying both sides by 6. Which is the LCD. So we end up with 6 times 5y over 6 minus 6 times 5 is equal to negative 6y plus 7/6 times 6, right? So we notice that these 6's cancel on the left side and these 6's cancel on the right side. So we have 5y minus 30 is equal to negative 6y plus 7. Now we move the y's to one side. Let's go to the left side. 5y plus 6y is equal to, moving the negative 30 to the right side, it becomes plus 30. And we get 11y equals 37. Divide both sides by 11. We end up with y equals 37 over 11. Okay? So I'm going to leave it to you to do the check. But I will tell you this, they both work. So the solution set contains two solutions, negative 23 and 37 over 11. Okay, don't forget, you must check. So just because I left it for you, it doesn't mean that it can be skipped. All right, so make sure you check it at the very least on the calculator the way I showed you, and we will proceed. Now we want to take a look at the absolute value inequalities. Okay, this is where the geometric definition is really going to show how efficient and intuitive it is. All right, so here when we interpret this, right, what do we interpret it as? Well, we're looking for find all x. I'm going to translate that into English. It's really helpful. I'm trying to find all real x whose distance from 0 is less than 3. Okay, so let's take a look. Here's 0. I know that 3 and negative 3 are exactly 3 units away, right? Their distance is exactly 3. So if I want the numbers whose distance is less than 3, think of it. What numbers would they be? Like, would 1 satisfy this? Of course, right? Because the distance between 1 and 0 is less than 3 because it's 1, right? How about negative 1, right? How about 2? Sure. How about negative 2? Of course, right? How about 2.999999999 forever? Of course, because that distance is going to be less than 3, right? 2 no matter how many 9s you have, is still less than 3, right? How about negative 2.999999999? Yeah, that's still going to be to the right of negative 3, right? So therefore, the solution set is going to be all numbers between negative 3 and 3, just like that. There is the graph, and we can write it. So the solution set equals all x such that negative 3 is less than x less than 3. That's in set builder notation. And in interval notation, it's negative 3 parentheses, negative 3 comma 3 parentheses. Remember, we want strictly less than 3. That's why we need parentheses. Okay, so the same reasoning is going to go into solving this next one. So in this time, we're looking for, if we're going to interpret it, we want to find all real x whose distance from 0 is greater than 3, right? So here again, we have 0 in the middle here. We have 3 to the right, negative 3 on the left. Now, we know that 3 and negative 3 are exactly 3 units away. So if we want numbers that are more than 3 units away from 0, we're looking at the kind of numbers like what? 4, 5, right? 3.1, etc. Or on this side, negative 3.1, negative 4, negative 5, right? So basically, if a number is going to have a distance from 0 more than 3, it's either going to be to the right of 3 or it's going to be to the left of what? Negative 3, right? So basically, if we graph it first, it's going to look like this. It's going to be those guys or those guys, right? So the solution set is going to include all x such that, let's deal with these guys first. Either x is less than negative 3 or x is what? These guys, greater than 3. Okay? Think distance and everything will make sense, right? You're looking for numbers whose distance, remember, absolute value of x means the distance between x and 0. You're looking for numbers x whose distance from 0 is more than 3. So it would have to be either numbers over here or numbers over here. So if we write it in interval notation, of course, for this piece, we know how to rewrite that. That's negative infinity to negative 3. With parentheses, union 3 comma infinity. All right, so think about that and we will move forward. Make sure you understand those two, because no matter how complicated they get, this is the foundation. If you get this, you'll be able to handle inequalities. All right, so what do you think is going to be the difference here? Yes, you said it right. You're going to include those endpoints. So here is 0, here's 3, here's -3. We're looking for numbers whose distance from 0 is either less than or equal to 3. That means this time -3 and 3 are also in the game, right? And then also all numbers in between, right? So when we want to write the solution set, we're going to have all x such that -3 is less than or equal to x less than or equal to 3. So we're going to have in interval notation bracket -3 comma 3 bracket. Okay, so the only difference is because of that equal possibility, the endpoints get thrown in as well. And the same here. We're looking for distance numbers whose distance from 0 is greater than or equal to 3. So that's going to include not just numbers less than -3, but also -3 itself, right? Like that, and also 3 or numbers larger than 3. So the solution set will include all x such that x is less than or equal to -3, or x is greater than or equal to 3, like so. So in interval notation, -infinity comma -3 bracket, because we want to include the -3, union bracket, because we want to include the 3, bracket 3 comma infinity. And that's it. So make sure you have that down. We'll move on. All right, then, you know, they can just throw in curveballs like this, but if you know how to handle those first ones, these are a piece of cake, right? Again, we're going to isolate the absolute value. It's a good time to pause and try it on your own. All right, so 3 absolute 2x minus 3 less than or equal to 7 plus 5. 3 absolute 2x minus 3 less than or equal to 12. And divide both sides by 3. So absolute 2x minus 3 less than or equal to 4. Now that we have isolated the absolute value, you can go ahead and interpret. You're looking for numbers or expressions whose distance from 0 is less than 4. So that means they're going to be between -4 and 4. So yeah, some motorcyclist is going crazy out there, so sorry if that's coming through. All right, so we want basically all this expression has to be between -4 and 4, right? And now we just need to solve this 3-part inequality, right? So remember, we're gonna add 3 to all 3 parts. We already saw these. And we end up with -1 less than or equal to 2x less than or equal to 7. Now we divide all numbers, all sides by 2 to get x by itself. Since that's a positive number, we can just go ahead and do it like this. We don't need to go to a new line because there's not going to be any change in direction. So we get -1/2 less than or equal to x less than or equal to 7/2. So it's easy to turn that into a solution set, right? You can just say the solution set equals all x such that this happens, or you can write it as bracket -1/2 comma 7/2 bracket, and that should do it for that part. All right, so a very similar approach for the b part. we're going to isolate. It's going to look very similar to the other part in the beginning. So 3 absolute 2x minus 3 greater than or equal to 7 plus 5. 3 absolute 2x minus 3 greater than or equal to 12. Divide both sides by 3. So absolute 2x minus 3 greater than or equal to 4. So we're looking for numbers whose absolute value is greater than or equal to 4. In other words, distance from 0 greater than or equal to 4. So either the number or expression has to be less than or equal to -4, or it has to be greater than or equal to 4, right? Remember, if you think about this as n, or some number n, you want the distance from 0 to be greater than or equal to 4, right? So remember, either it has to be 4 or higher, or -4 or lower. This is just a prep graph, right? It's not the graph of the solution set, because we have this complex expression inside the absolute value. So we just have to solve these inequalities to get the actual solution set. So 2x is less than or equal to -4 plus 3. 2x is less than or equal to -1. Divide both sides by 2. So x is less than or equal to -1/2. On this other one, 2x is greater than or equal to 4 plus 3. So 2x is greater than or equal to 7. So x is greater than or equal to 7/2. So you want, for the solution set, all x such that x is less than or equal to -1/2, or it's very important that you say or, because if you say and, there won't be any such numbers, right? Think of it, even up here, is there any number that's less than -4 and greater than 4? That's impossible, right? That's why you have to make sure that you're logically sound and you say or. Or x is greater than or equal to 7/2, right? And in interval notation, it's going to be -infinity to -1/2, parentheses on the -infinity, bracket on the -1/2, union, bracket 7/2, comma, infinity, parentheses, okay? And that is how you handle those. So no matter how complex they get, if you get the basic idea of what it means with absolute value as distance, then it all becomes very doable. So practice those and then we'll proceed. Let's go ahead and look at some special cases for inequalities as well. All right, so here we're looking for numbers whose distance from 0 is greater than or equal to -4. All right, so a good question to ask is, can you think of any number whose distance from 0 is not greater than or equal to -4, right? Any number that you plug in is going to work. Think about it. How about 0? Is the absolute value of 0 greater than or equal to -4? Is 0 greater than or equal to -4? Yes, it is, right? Think of a negative number like -5. Is the absolute value of -5 greater than or equal to -4? What is the absolute value of -5? That's 5. Is 5 greater than or equal to -4? Yes, it is, so it checks out. Any number you plug in is going to work, because any distance, what's the smallest possible distance? 0. Is that greater than or equal to -4? Yes. So all other distances, which are absolute values basically, are going to be greater than or equal to -4. So that means what? That means the solution set is all real numbers. You can write it like that, or you can say R, like that. All right, so that one will always be true for all real numbers. How about the next one? You're looking for numbers whose distance from 0 is less than or equal to -4. Is that possible for a distance to be less than or equal to -4? That's impossible, right? Sometimes people say, what about -4? Well, what's the absolute value of -4? That's 4. Remember? That's not less than or equal to -4. So in this case, you're not going to find any x that satisfies this. There is no such x, right? Whose distance from 0 is less than or equal to a negative number, right? So this time the solution set is what? Empty. No solution. All right. How about this one? You're looking for numbers whose distance from 0 is less than or equal to 0. You know, if you break this up as two statements, because it is two statements, one of them is absolute value of x is less than 0, or absolute value of x equals 0. This part will give you no solution. There's no such x, right? Whose distance from 0 is less than 0. But there is one number on this side that does satisfy this, and that's what? That is x equals 0. See? So therefore, in this case, the solution set is going to have a single solution, and that is what? 0. All right, so think about that for a minute. Sometimes these need a little bit of analysis. What about this one, though? This one is looking for real numbers whose distance from 0 is strictly less than 0. Is there any such number? No. There is no, because what does less than 0 mean? It means negative, right? There is no or equal option here, right? So this is looking for all numbers whose distance from 0 is strictly negative. There are no such real numbers, right? No such real number. So therefore, the solution set here is what? Is empty. All right, very good. How about this one? Numbers whose distance from 0 is either positive or 0. Well, let's think. Any number, right? Any number is going to have a distance from 0 that's either 0 or higher, right? So therefore, what's the solution set here? Yep, you said it. All real numbers. What about this one? I'm going to want you to pause and think about this one for a minute, because it's a little bit different from this, but it's not that different, so think about it. This time we're looking for only numbers whose distance from 0 is strictly positive. Well, that's true for all numbers, right? Except what? Well, except 0 itself, because the distance between 0 and 0 itself is not positive. So this one is going to have all real numbers as solutions, except what? Except 0. So that means the solution set is equal to all x such that x does not equal to 0. So how do we show that in a graph? Well, here is 0. You're going to have a hole at 0, but everything else is going to be a solution. So basically, it's going to, in interval notation, it's going to be all these guys, which is negative infinity to 0, with parentheses, together with all these guys, which is what? 0 to infinity. Okay? So there is that. So a little bit different from this. This one included all real numbers. This one included all of them except that one number, 0 itself. Okay? So these are really good problems to think about, because this is how you expand your mathematical horizons. Okay? And also, the more interactively you handle these video lectures, the more you're going to get out of the class and these videos. So make sure that you're handling these videos in a very active way by participating, because just watching what I do is going to have very, very little benefit for you. Okay? All right, let's go ahead and move on. All right, the last thing we want to do for the day is look at absolute value and how it can help us find the distance between 2 points on the number line. Okay? All right, to that end, let a and b be two distinct real numbers. Note that the absolute value of a minus b can be written as the absolute value of negative b plus a, right? We're just changing the order of these with the commutative property of addition. So notice that here I can factor out a negative 1, and that leaves me b minus a, right? And if I go ahead and break this up, because remember, this is true. If you have absolute value of a times b, you can write that as the absolute value of a times the absolute value of b, okay? So that's what we're doing here. So we're saying that's going to be the absolute value of negative 1 times the absolute value of b minus a. You cannot do that if there's addition or subtraction. You can only do that if there's multiplication or division, okay? So now what is the absolute value of negative 1? That's 1, right? Times the absolute value of b minus a, which is equal to what? Just the absolute value of b minus a. So in other words, when you take the absolute value of a distance or a difference, it makes no, the order doesn't matter. The absolute value of a minus b is exactly the same as the absolute value of b minus a. Look at some examples and it'll make sense, right? What's the absolute value of 2 minus 5? Well, that's the absolute value of negative 3, which is 3. What's the absolute value of 5 minus 2? Well, that's the absolute value of positive 3, which is 3. So notice the absolute value of 2 minus 5 is exactly the same as the absolute value of 5 minus 2. How about the absolute value of negative 2 minus negative 5? Well, that's going to be the absolute value of negative 2 plus 5, which is the absolute value of 3, which is 3. How about the absolute value of, if we change the order, negative 5 minus negative 2? Well, that's going to be the absolute value of, that's a typo, that's going to be negative 5 plus 2 is negative 3. Okay? But that's also what? What's the absolute value of negative 3? That's 3. So again, we showed that the absolute value of negative 2 minus negative 5 is the same as the absolute value of negative 5 minus negative 2. So the absolute value of a minus b and the absolute value of b minus a give you the exact same result. Now we can apply that to distance between two numbers. Given two distinct, remember, when you see distinct in mathematics, that just means unequal, right? Different, that's what it means. So given two distinct points, a and b on the number line, then one of the following has to be true, right? Either a is less than b or a is greater than b. You see that? Or b, which is the same as saying b is less than a. So if a is less than b, then the distance between a and b is, remember, you can just say the bigger number minus the smaller number, right? But notice that's the same as the absolute value of b minus a, right? Which is, we just saw in the previous screen, is the same as the absolute value of a minus b. So the distance between a and b can be found by finding the absolute value of b minus a or the absolute value of a minus b. So what's the beauty of it? You don't need to worry about which number is larger, which number is smaller. You want to find the distance between two numbers, just take the absolute value of their difference, and you can take the absolute value of the difference in any order that you like, okay? Now, if a is greater than b, the distance between a and b is going to be the absolute value of what? A minus b, right? Because a is the larger number, right? So it's the larger minus the smaller will always give you a positive value, right? So, but that's the same as the absolute value of a minus b, right? Because why? Because this is positive. That's why the same thing happened here. Why is b minus a the same as absolute b minus a? Because b minus a is positive, because b is greater than a. Here, why is the a minus b the same as absolute a minus b? Because a minus b is a positive number. What's the absolute value of a positive number? Itself. You get it? But notice that's the same as absolute value of what? B minus a. So again, you can find the distance between a and b by finding either of those two absolute values. So the moral of the story is, if you have two different numbers on the number line and you want to know their distance, you don't need to worry about which one is smaller, which one is larger. Just take the absolute value of the difference in any order you like and you'll get the distance, okay? And that's all there is to distance. All right, here we're going to find some distances, right? Notice I'm not going to worry about which one is which, bigger, smaller. You want a distance between these two. I'm just going to go the absolute value of 2 minus negative 9. So that's the absolute value of 2 plus 9, which is the absolute value of 11, which is what? 11. Now, I could have just as easily had gone absolute value of negative 9 minus 2. That becomes the absolute value of negative 11, which is 11. See? Makes no difference which number you subtract from which number. How about this next one, B? Well, I'm going to go with absolute value of negative 7 minus negative 9. Remember, the one number minus the other has to go inside the absolute value. So you get absolute value of negative 7 plus 9, which is absolute value of 2, which is what? 2. Notice you could have just as easily done absolute value of negative 9 minus negative 7, which is the absolute value of negative 9 plus 7, which is the absolute value of negative 2, which is 2. All right. Same the result, right? How about these ones? Same business. We don't need to worry, compare the fractions, see which one is larger, which one is smaller, because, where did I? Okay, these screens, they're a little bit different from whiteboards. They're very touchy. All right. So here, I'm just going to go absolute negative 1/2 minus negative 2/7, right? Remember, one minus the other. Doesn't matter which order you do it in. So that's going to be the absolute value of negative 1/2 plus 2/7. Common denominator is 14. So I need to multiply this by 7, so I have to do the same on the top. I need to multiply the 7 by 2, same on the top. So the numerators now become negative 7 and 4. So I get absolute value of negative 3/14, which is the same as what? 3/14, okay? You could have done it the other way around. I want you to try that. Try this. Absolute value of negative 2/7 minus negative 1/2, and show that you end up with the same thing, okay? Same business with this last one. You can go absolute value of negative 1 minus negative 3¼ Or if you don't like that, you can do the absolute value of negative 3¼ minus negative 1. So that's going to be that this one is going to give me negative 1 plus 3¼ All right. Which is basically 3¼ take away 1, so it's 2¼ And of course the absolute value of 2¼ is just 2¼ If you do this one, you'll get the absolute value of negative 3¼ plus 1. So it's going to be the absolute value of negative 2¼ which is once again 2¼ All right, so again, you want to find the distance between two numbers, take the absolute value of their difference in any order you like. All right, here's an interesting kind of problem that you'll encounter sometimes. Find all real numbers that are within half a unit of 8 or 0.5 units of 8. So here's what we can do. Let x be a real number that is within 0.5 units of 8, right? Then that means the distance between that number and 8 needs to be less than what? 0.5, right? That's what it means to be within 0.5 of something, right? Recall that the distance between x and 8 is given by absolute x minus 8, right? So you want absolute x minus 8 to be less than 0.5. Now we just need to solve this inequality with absolute values, which we know how to do. That means if the absolute value of x minus 8 is less than 0.5, that means x minus 8 must be between what? negative 0.5 and 0.5. And if we just solve by adding 8 all around, we end up with negative 0.5 plus 8 less than x less than 0.5 plus 8. So x has to be between 7.5 and 8.5. Therefore, all real numbers between 7.5 and 8.5 are going to be within half a unit of 8. Now, you're sitting there thinking, gosh, I could have told you that without having to go through all this complex mathematics, right? But the whole point is to apply the concepts in a way that's going to stick, right? And to give you some practice. And all of this, remember, you always get the question, where am I going to get to use this in real life? Think of it as mental gymnastics, right? Where are you going to use some of the fancy moves that you do in a gym, right? Well, you're not going to go out and start doing presses and stuff. But when you need to lift a heavy weight, right, guess what? The training that you did is going to be there, and it's going to help you lift it. When you need to run away from some guy who wants to hurt you, guess what? That training is going to be there to help you do that, right? Well, the same thing with this. When you need to apply yourself and solve some kind of a logical problem in your life, this training is precisely what's going to help you get through and get it done, okay? So that's what we're doing here. Make sure you understand that, and we'll proceed. All right, so here we're going to write each of these statements using an absolute value inequality. K is no less than 5 units from 8, right? So what does that mean? That means the distance between K and 8 is greater than or equal to what? 5 units, right? So you can do it in stages if you like. You can say the distance between K and 8 is greater than or equal to 5, right? But what is the distance between K and 8? Remember, that's just the absolute value of their difference. So there it is. That's the first statement translated into an inequality involving absolute value. All right, how about this next one? N is within 0.001 unit of 6, right? So that means the distance between N and 6 is what? Less than 0.001. So we get absolute n minus 6, because that's the distance between n and 6, is going to be less than 0.001. Okay? And that's how you would translate those as inequalities. All right, let's do this last one for the road, okay? In quality control situations such as filling bottles on an assembly line, we often wish to keep the difference between two quantities within some predetermined amount called the tolerance. Suppose y equals 2x plus 1, and we want y to be within 0.01 unit of 4, right? So for what values of x will this be true? Think about this for a minute. I want you to pause the video. You can do this and then come back and see if we agree. All right, notice that we want the distance between y and 4 to be less than what? 0.01, right? So we want the distance between y and 4 to be less than 0.01. So what is that? That means absolute y minus 4 is less than 0.01, right? So how do we solve that? We know how to solve that. But before we do, let's go ahead and substitute for what y is. Y is 2x plus 1. So 2x, absolute value of 2x plus 1 minus 4 is less than 0.01. So absolute value of 2x minus 3 is less than 0.01. So that means, now remember, what numbers have an absolute value less than 0.01? Numbers between negative 0.01 and 0.01. So 2x minus 3 must be between negative 0.01 and 0.01. So now we just have to solve this three-part inequality. We'll add 3 all around. So we get negative 0.01 plus 3, that's 2.99, less than 2x, less than 3.01, right? Now we need to divide by 2 all around, right? So since it's a positive number, I'm just going to handle it quickly like that. So let's see, I've changed the resolution on my screen to get a little bit more working space. I didn't think about this negative consequence of the calculator becoming so small when you increase the resolution. All right. So we get 1.495 less than x less than, now we do 3.01 divided by 2, 1.505. All right, so there we have it. So for the values of x for which this will be true will be the x values between 1.495 and 1.505. All right, and I know that was quite a bit of mathematics there, so that should do it for today. You take care, and we will see you for the next lecture.